Ever wonder why the ground beneath you shakes during an earthquake? It's a question that has perplexed mankind for centuries. You see, earthquakes are an intriguing natural phenomenon, resulting from a sudden release of energy in the Earth's crust. This energy doesn't just dissipate though. It travels, it moves, it vibrates in waves. These aren't just any waves, they're seismic waves, the unseen power below. Yet this leaves us with another question. But what are these seismic waves and how do they cause such destruction? Imagine throwing a stone into a pond. The ripples that spread out, those are like seismic waves. As we venture deeper into the world of seismic waves, we encounter two main types: P waves or primary waves and S waves or secondary waves. P waves are the speed demons of the seismic world, always the first to be detected. They move in a compress and expand motion, much like the way sound travels through air. Picture a slinky stretching and compressing. That's a P wave in action. Hot on the heels of P waves, we have our S waves. These waves prefer a more dramatic entrance, moving in an up and down motion. Imagine a snake slithering on the ground, and you've got the essence of an S wave. When these waves join forces during an earthquake, they cause the ground to shake, creating the tremors we feel. And it's this shaking that tells us an earthquake is underway. Now that we know how earthquakes happen, can we predict them? Predicting earthquakes, a tough nut to crack. It's like trying to predict when a teapot will whistle. Scientists can't pinpoint the exact moment an earthquake will strike, but they've got a trick up their sleeve, identifying seismic hotspots. These are areas where earthquakes have frequently occurred in the past and are likely to rumble again. Just as storm chasers follow weather patterns, earthquake trackers follow these seismic patterns. So, the next time the earth shakes beneath you, remember it's the seismic waves at play.